pursuing mechatronics engineering, and we'll be taking you through stress analysis in nature and real-world applications with special consideration on the Sierra Nevada mountain range in the United States. So first and foremost, let's just understand what is stress. So stress is actually an effect that is felt by materials as a result of application of forces, and we basically describe it as force over a cross-sectional area. Um, so stress actually finds a lot of application in nature, and it can be described in physics. And we can see some end effects that are felt in nature as a result of stress include earthquakes, volcanic eruptions, mountain formation, rock deformation, continental drift, and glacial formation. Um, Stress contributes a lot to tectonic plates movements. Uh, which are responsible for shaping of Earth's surface over geological timescales. These movements of tectonic plates can happen over millions of years, as we shall see in the formation of the Sierra Nevada mountain range. And these tectonic plates are basically just massive slabs of the Earth's lithosphere that float on the semi-fluid asthenosphere beneath them. And by the virtue that they float, they tend to move against each other, slide past each other, move towards each other, move past each other, and this results in the formation of three types of stresses, predominantly compressional stress, tensional stress, and shear stress. So for the Sierra Nevada mountain range, it is a mountain range located in the western United States between the Central Valley of California and the Great Basin, formed as a result of compressional stresses. It actually spurs to some part of the Cordillera, some part of Nevada called the Cordillera, since it is actually a very huge and continuous mountain range, as you can see in the picture. So, on the history of the formation of this mountain range, 20 million years ago, crustal extension associated with basin and range province caused extensive volcanism in the Sierra. And Sierra Nevada started to form on a block of crust between the coastal range, that is part of the Pacific plate, and the basin and range province that is the North American plate, started to tilt to the west as heat from the basin and range extension thinned the eastern part of the block, making it buoyant. That was the North American plate became buoyant over the Pacific plate, and it tended to slide over it, and which resulted in the formation of these table mountains, and actually some river channels were actually also formed. So the predominant stress that contributed to the formation of this mountain range was compressive stresses, and the Sierra, as I stated earlier, the Sierra Nevada mountain range is located on the western side of North America, and it is attributed to the interaction, the compression that happened between the Pacific and the North American plate that that resulted in the formation of this mountain range. So here is a picture. I tried to depict the interaction of these two types of plates, whereby a subduction zone was formed, whereby the oceanic plate, that is the Pacific plate, tended to slide under the continental plate, which is the North American plate, since it was denser, and this resulted in high compressive stresses and buckling, and as a result, the mountain range was formed. The mountain range is able to withstand external forces as a result of the structural components, the geological features, and the materials that are involved. For the structural components, you have the fault block structure, the existence of faults, and they tend to enable the release and the release of extensive forces, which results in reducing the risk of catastrophic rupture, and also joints are actually part of this structure. Another factor that contributes to being able for this feature to exist as it is stress distribution. Compressive stresses, extensional stresses, and shear stresses play a huge part in enabling this to be. The third is the materials involved. The mountain range comprises mostly of granitic rocks and metamorphic rocks. Granitic rocks are the major constituent, and they are very hard and they are very resilient and are resistant to weathering, and which contributes to the jagged and high peaks of this mountain range. Metamorphic rocks were formed as a result of the high temperatures due to the extensive compression of forces, and they are actually very strong and resilient and have also contributed to how the mountain range looks like today. So it is very important to understand stress in nature, because you can be able to understand or look into resource exploration, infrastructure design and safety, agriculture and land use planning, and geological hazards mitigation. Um, there are potential engineering lessons that we can be able to take from the formation of this mountain range. One is on earthquake engineering. This Sierra Nevada region is actually a very highly seismic active region, and being able to understand it can be used in other seismic active regions to see what measures can be taken. Another thing is in civil engineering and infrastructure design, basically coming up with roads, bridges, tunnels in these very high rugged terrain regions, and sustainable resource management in understanding how these resources are generated, the water resources, the minerals that are exposed, and how they can be used. So that is all from me. Thank you very much. I have been able to look at stress distribution in nature with special emphasis on the Sierra Nevada mountain range in the United States. Thank you very much.